Right, so the previous charts that we've been talking about have mostly dealt with categorical data. So you have some sort of measure that is grouped, such as by gender or by department or political party or whatever it is. Now we're talking about multiple continuous variables. These could be measured in whole numbers or decimals, whatever, as long as they're numbers and not categories. So our classic example of this is going to be our scatter plot, which the picture here shows a bubble chart, which is basically a scatter plot with size, a paired scatter plot as opposed to a regular one. They're all paired, and a slope graph. So what the chapter actually covers are scatter plots, parallelograms, and paired data. So let's go through these. Okay, so scatter plots. So traditionally, a scatter plot shows every single point in your data along an XY axis. So basically, for every row in your data, this is showing two different columns, so that each point represents one row. Tableau is not actually set up to do this as its go-to. It's actually designed to show it as aggregated as the default, which is interesting. And so I'll go ahead and actually switch over to Tableau. So if you just click on two different measures, so here I have what is the relationship between the overall ratings and career opportunities? That's the question being asked here. So when you click on these and just throw them in, you get this one dot. That's definitely not a scatter plot by itself. If you have data that looks, so this particular data, all the individual ratings are in whole units because it's a Likert scale of rating 1 to 5. So it's going to look really dumb when I do this. But if you have other data that's a longer scale, it won't look as dumb. But you can actually click this button here to unaggregate it, and then it'll split it out. Also notice all the nulls here, so you can just tell it to filter it. There we go. So everyone who didn't answer that question are now filtered out of this graph. Still doesn't look good just because of the type of data that we have here. But let me aggregate it back. How can we make this look a little better? So the reason why this is often looking at just aggregated one, because it's meant for big data. Tableau isn't meant necessarily for like a small amount of data points. But we can start adding in these, and I don't like this there, I want to color. Okay, so here we have the different companies, and so it's just showing their average ratings here, but you can see that the relationship between these in general, so you can see that like in general there is a there seems to be a relationship going on, a positive relationship. It looks fairly strong there. You can see that Facebook is much higher on both of these than the other ones, followed by Google, and our Netflix is the lowest on both of these measures. And so that pattern holds across these different companies. We can also add in a second category here. So now I've added job status in here. It's automatically done it by shape. So we can scroll over that and we can see that former employees are the plus signs and current employees are the squares. Again, even looking at the different categories there, we have a trend going you also see that, generally speaking, the former employees are weighting things lower than the current employees, maybe because they left the company. So they're either already reached that point where they wanted to quit, or they don't feel beholden to the company in any way. You can also do things like job titles was something that I had a lot of data on, right? So what if we did that? Actually, I'm going to take that off as well. So even job title, we can see that there's a strong trend here, and also that kind of grows up at the top, right? So you can play around with the different ones here to see how it looks. Yeah, how it ends up looking and stuff. But generally speaking, for my data, I'm not interested in job titles at all. I'm really looking at these two. Job status as the shape. And of course you can put these on size as well. Does this make sense at all to do? No. So the size ones really only make sense when you're looking at things that are actually ordered by size. So yeah, so generally stay away from those, stick with the shapes and the colors. Those are traditional ones. Okay. And you can see over here on the right side that we have our legend that tells us the companies and the job status, what they are. We can add in trend lines. So now again, remember these are very funky because they're on these aggregated ones. See how when we unaggregate it, the lines are actually all positive. The cool thing is that it does actually give us, when you mouse over these different trend lines, it does actually give us the regression. So this is where there's like, wait, I don't want to talk over your heads with this. Trend lines are also called regression lines. So if we did a simple regression between these two variables for each of these different categories separately, that is what we get there. And so you see that these are, carefully mousing over, these are all significant. So in other words, there's a significant relationship between the overall and the career opportunities. Okay, so there we go. But then again, you can see that when you do the aggregate, the math is actually doing it on the aggregated itself. So you want to be really careful about applying these trend lines to these aggregated measures, aka don't do it. Okay. And if you take those also with the trend lines, you can get this describe. And then for the folks that have gone through the stat stuff, you get all this stuff in here. So you see that it's all significant, it's all beautiful. Gives you like degrees of freedom and everything in here. So that is our correlations, or our scatter plots, really. Correlograms. So we looked at an example of this in class when we were picking apart the tables, because they fall in between those kind of areas. So they tend to look something like this. They can be made out of circles and different shapes. You can actually put the numbers in there. So the example that we saw, they had specifically added in the numbers, or the colors for the numbers, to show significance. Here, the colors are simply a matter of the strength of the correlation, which I think is what, as a group, the group that looked at that was like, I think they originally were thinking that it was something like this, because this is usually what you see with the parallelogram. So this is another one of those ones where, in order to do it in Tableau, you're going to need to do a lot of extra calculations and stuff. So I included a link in there in case you are interested in attempting this. Again, just it takes a lot of time to figure all this stuff out, and I didn't want to subject the whole class to me trying to figure out this kind of stuff and pushing it back even later. But yeah, there are instructions, and you find instructions on the internet as well. The next one that the book actually talks about is PCAs, which are another stats thing that is beyond the scope of a class like this. But if you have taken a stats class and you know what a PCA is, or an EFA, it provides a little guidance to actually visualizing them, although they're not usually visualized. So that's interesting, but I won't worry about that one. This last one that they talk about, the slope graph or paired graph, it's basically a 2-point line graph. And we'll talk about line graphs next week with the trend stuff, so I'm not going to go over that in Tableau right now. But yeah, it's a 2, and then they gave an example of a 3-point graph. These are all ordered numbers, for example, years, just showing the trend lines between 2 points. You know, it's pretty simple.